Now for criterion C, this is my raw data, and as you can see, we have the distance from pivot in meter, and we have 3 reading for the force. What you need to do is to find the mean of the readings for the 3 forces. So you will just add them together, divided by 3 for each reading, and then you will get a number. Let me do it. 9.90 plus 9.88 plus 9.93, all divided by 3. This will give you on the calculator 9.90333. And okay, so how can you decide how many decimal places you need to take? In fact, it's not about decimal places, it's about significant figures. It's about how many digits do you have. And as you can see, my numbers are all to 3 significant figures. So I need to take only 3 significant figures, applying the same rule. If the number after the 3rd significant figures is greater than 5, then you need to round this up to 1. If not, if it's less than 5 or equal and less to 5, then you keep it as it is. So what's my answer then? My answer is 9.90. Remember that since this is mean, since this is the mean, then it doesn't have any unit. So that's my answer, and you just put the answer in the table, and this is the result that you will get. Okay, so I filled all of these. Don't forget to put the title with the correct unit and the title with the correct unit. And now what about the moment? Here you need to apply the formula, which is the moment is equal to the force multiplied by the distance. So for each force that you could get, multiplied by the distance, and you will have the number, and we follow the same pattern. It's 3 significant figures, and that's it. Okay, now after that you need to plot the graph. So I'm going to take my data, and okay, so this is my data, and this is just an evidence for the calculation of force and the calculation of the moment value. You need to plot these two. Okay, so this is my data that I will plot on the graph. Now, as you can see, distance will go to the x-axis, force will go to the y-axis. Next, you're going to plot the dots. Of course, you will place the labels and the correct scale. I'm not gonna talk about this. You should all know how to do it. Okay, so now that I have my dots, I need to draw the curve, the best fit curve if you want. Now, almost everyone, they did the curve in this way. Considering that this is the dot that is the outlier or the error. Do you think this is right? Well, we cannot decide whether this is the outlier or this one or this one. In order to do that, we need to see the pattern in the table that I have, the processed data that I have. Okay, so if I compare the numbers of the moment, you can see how this is 0.99 and then 1.39, then again 0.99, 0.98, and 1.01. As you can see, this is the point that breaks the pattern, because all of them have the same moment. All of them were having the same exact tiltation degree, if you want. So this is in fact the point that should not belong to your graph. So whoever drew the pattern of the graph this way, this is completely wrong. It's so wrong. Your graph should look like that. Okay. Yes. And so which one is the outlier? That's my outlier. Okay, and the outlier is due to human error. It's due to a mistake while doing this reading, the second one. Okay, I'm gonna talk about all of this in strand II and 3I, IV and V. Now for criterion C strand 2, you need to accurately interpret data and explain results using correct scientific reasoning. This is done by analyzing the graph and see the pattern that your graph had. Now, this is not a line graph, that's a curve. That's for one. And the curve has a logarithmic pattern. A logarithmic pattern is a pattern that shows that as the x-axis increases, as the value of the x-axis increases, the value of the y-axis decreases. Okay, so as you can see, we're jumping from a value to another that is higher in the x-axis, but then we're jumping from a value to a lower value on the y-axis as the x-axis increases, the value of the x-axis increases. So that's the first thing. You need to mention the pattern of your graph. What does a logarithmic pattern represent? So I'm gonna say it represents an inversely proportional relationship. And then now, so far I'm being so general, I need to be more specific to my own graph. So I'm gonna say the pattern of the graph shows that as the distance in meter increases, the force measured decreases. Okay, and it was noticed that before that the product of the force by the distance is a constant number that is almost equal to 1 Newton meter, which means that the turning effect of force was controlled. So this is what you're gonna write in order to interpret your data. You're gonna say the graph plotted has a logarithmic pattern which usually represents an inversely proportional relationship. I'm being more specific for the graph that I have. So the pattern shows that the distance from the base to the position of the rubber increases, the force decreases, and it was noticed, second thing you've noticed by interpreting the data that we have, that the product of the force by distance was kept as a constant number. Okay? Now, for strand 3, I need to evaluate the validity of the hypothesis. So, do my now for strand 3, we need to evaluate the validity of the hypothesis based on the outcome of the scientific experiment. You need to refer to the evidence from the data collected and from the graph plotted. So we're gonna start by saying, considering the graph plotted and the data recorded on the previous page, we can confirm that the hypothesis was verified. How can we see this? First, we're gonna say this can be seen by checking the logarithmic shape of the graph, which usually represents an inversely proportional relationship between what and what, between the distance in meter and the force applied in Newton. Also, by analyzing the force from the processed data table that we have or we collected, we can notice that the force decreases from 9.90 Newton to 2.02 Newton when the distance in meter from the pivot increases, and that's based on the data collected. This is what they want us to show. Okay, what else? I can say that, last thing, let me show you the answer. I can say that referring to the principle of moment that states moment is equal to force multiplied by distance, we can see how the moment, which is approximately equal to 1 Newton meter, which proves that the inversely proportional relationship between force and the distance. What do I mean by that is that if I rearrange this formula, okay, so if F times D is equal to a constant number, this means that the force is equal to the constant number divided by the distance. And this shows that force and distance are inversely proportional. Okay? So Now, next strand IV, what they want is to evaluate the validity of the method. Now, here, you need to return back to the method to read it and to see the strength point of the method and the weakness points of the method. Usually, what I do is I do like a table and I show the positive things and the negative things. Okay, for the positive things, we can see that in step, just a second, yes, this one. In step 6, it shows that we're repeating the experiment 3 times. So that's a good thing, that the experiment was repeated 3 times. So 3 times repetition. Okay. Also, we can see that the independent variable and the dependent variable were given a good scale. So I have a scale or a range for my independent and dependent, and the way we are manipulating the independent and measuring the dependent is really clear. Okay, so these are the positive things about my method. Now, what is the negative thing about the method? The limitations, if you want, of the method, the thing that made your method not valid enough. It's this number that we noticed, that we all noticed, that there is something wrong with it. Okay? So, what was something wrong in your method that made this error? Think about it. And you will see that this is due to human error, it's true, but the main error was that the degree or the angle that the clamp stand must tilt wasn't clear or wasn't controlled in a good way, in an accurate way. Okay, so this is what I have. This is my pros and cons for the method. This is how I evaluate the method, and this is the paragraph that I wrote. By looking over the results, we can state that the method was reliable. Now, I will highlight the keywords that are extremely important for you to use. When we want to evaluate, you will talk about 2 things, about the reliability and the validity, which is this one. Yeah. So we talk about the reliability and the validity of the method. So by looking over the results, we can state that the method was reliable for many reasons. What are the reasons? First, the measuring of the force in Newton was repeated 3 times before getting the average. Moreover, the method could specify a clear dependent and dependent data range describing how to manipulate the IV and how to measure the dV. However, there are some limitations that made the method at some point not valid enough. So you see how I am talking about 2 things in evaluation. We could notice by analyzing the data that there was an anomalous result with the second reading of the force in Newton. As the distance, I need to state this, I mean I need to outline this, not only to state it. So you take the readings from the table and you just write them in the paragraph. So you say, as at distance 0.20 meter, the Newton meter showed a reading of 6.93 Newton. This is due to what? To human error while tilting the stand about its base. Now, the inaccuracy in the control variable by not precising the angle or degree that the clamp stand must be tilted by, or to, when applying the force caused this significant difference in results, and the error could appear on the graph as an outlier value. I used everything I could from the data in order to show that there was an error, there was something that made your method invalid, not valid enough if you want. And I was using scientific reasoning, I was using examples, so that's on a level 7 to 8. One thing I want to add to my evaluation in strand IV, that you should not talk about how
to fix the problem here. So you just talk about the problem here, you're just evaluating, you're stating, listing, describing pros and cons, nothing else. Okay? In strand V, where you need to suggest and explain improvements, this is where the problem. Okay, so pay attention to that. That's a very important point, that in strand IV, in criterion C, we just evaluate by giving pros and cons. In strand V, we fix the problem, we give solutions.
Now, last thing is suggest and explain improvements or extensions to the method. I usually do the same thing, so I will have a table to show the problem and then what improvement or solution you can have. For the problem, you can say that the error in the value of the force recorded in Newton. How can we fix this? By using a protractor. We need to add an apparatus to our materials. We use a protractor to precise the angle at which the stand must be tilted. The results were not very accurate. Maybe we could use a digital Newton meter scale instead of a scale spring. Okay, and for the safety measures, we could add the goggles in case the rubber band snaps out. Now, this is for my suggestion for the improvements. I need now to suggest an extension. Well, since this is related to moment, the things that we know about moment is that we have the formula, and second thing, we know the law of principle of moment, which is clockwise and anti-clockwise moment, etc. So if we investigated this, an extension for my investigation is to what? To maybe we can investigate this law. Okay? In order to see the law of conservation of moment. That's all.